Motherboards Part 2. In this nugget, I'll be your tour guide as we take a look at the motherboards. And this will be part 2 of our discussion of motherboards. We'll just get a look around the motherboard and get visual identification of the various parts and components, and in many cases, how to plug the various devices into them. Although many of these will be covered in more detail in videos, or nuggets as we call them here, dedicated to them. For example, CPU and memory will have their own nuggets on that. But we'll have some of the things identified such as I/O. We'll take a look at things such as USB, I/O. We'll take a look at serial ports. We'll look at what else? Firewire. Some of those kinds of things for I/O. Sound. You know, that sort of thing. We take a look at CPU as well, at least in terms of the socket and the basics of it. We'll also take a look at some of the basics of the memory slots as well, and we'll take a look more detail about the installation of those at a future point in time. We look at the slots so that you can identify where to install expansion cards. We take a look also at the power connections, which of course you're going to need to be able to run the motherboard. We take a look at the panel connectors so that it can interface with your case, and things such as the power and LED and reset switch and the like. And then we'll conclude with a look at some of the other things such as the IDE connector or enhanced IDE connector, which is more likely in more current computers. Or if you're in an even more current computer, you're more likely to find a serial ATA connector. Remember that these can also be called AT attachments or parallel AT attachments for these two kinds of connectors respectively. Alright folks, before we get started here today, I gotta tell you, I might get interrupted during the recording. And of course, I'll pause the recording if that happens. But you see, today is my wife's birthday. And she told me earlier this morning that for her birthday, she wanted me to do whatever she told me I had to do. To which I snidely remarked, how is this day different than any other day? But who knows? Maybe she'll have me vacuum the carpets and mop the floor, and I don't know. She'll boss me around like little Cinderella or something like that. Little Cinderella. That's funny. That's what they used to call me in high school. Anyway, let's go ahead and move along. We're going to take a look here at motherboards, and we're going to continue this discussion by taking a look at an actual motherboard that I'm using right now, in fact, to record this video. Because you see in the back of this, I've plugged in my USB headset and microphone, and as I speak, it goes somewhere through this motherboard, and then it eventually gets saved as a video file, and voila, now you're listening to it. So I'm going to cover the back connectors over here at a later point in time, but we'll get started here by at least identifying what's over there. Let me zoom in a little bit here, and we'll start in this quadrant right here. Now, some things also will be proprietary to this particular motherboard manufacturer, which happens to be ASUS. You can see their name right there sideways, but that's ASUS. And we have various ports over here along the back. Again, we'll take a look at a second picture of that. Also, the stuff I was mentioning earlier that's proprietary just to them might be something like this one little item that you see right back in here. What that does is it allows me to plug in a remote control, which then allows me to increase the overclocking or change the overclocking of this motherboard kind of on the fly. Also, some things that many motherboard manufacturers have is going to be these heat sinks that you see right here, and that's these blue finned items right here. And what these do is it helps to wick away heat from the motherboard and the various components. There's various shapes and sizes of heat sinks. They're made of differing materials, although mostly they're going to be made of aluminum. Sometimes they're also made of copper. And then besides these kinds of heat sinks that you see here, which different manufacturers put in different locations, you'll always see a heat sink over the processor because it definitely needs to have special cooling applied to it. And then having zoomed in a little further over here, we see one of the two power supply connectors. This one right now out of the box was set up for a 4-pin connector that you can see right there, and it's keyed in such a way that you can only plug it in one way. That way you don't plug it in, you know, sideways, backwards, or upside down or something. And then my particular power supply is capable of actually an 8-pin connector here. So I removed this black cover that you can see over here, and now I plugged in an 8-pin connector, which gives me 12 volts over there. Again, we'll talk more about power supply later on. Here, of course, is my where I would put in my processor or my CPU. This has nothing in it right now. This is right out of the box, and it's got a plastic cover in there to protect the grid. Okay, there's a grid of connectors or contacts down in there that's very important to connect. That can be extremely fragile. We'll talk more about installation, of course, of CPUs when we talk more about CPUs in particular. And then there's also here some holes that you can see in all 4 sections of this. I can't seem to draw a circle today, but there we go. And what this does is allows me to fasten onto this a heat sink. I'm using a liquid-cooled heat sink over the top of my processor, which is installed, of course, by now. In order to cool this, you need a couple of different things. One of those is an actual just good heat sink. It might be some kind of a metallic item with fins in it with a fan on top, or it might be liquid cooled like mine is. Regardless, you'll have a couple of fans here as well, and there's little connectors here that you can use to plug those in. And this one would be one of the many chassis fan connectors that would be useful for, like if I have a fan on my case, an exhaust fan or a supply fan or something like that to help cool off the case. And then the one beneath it here, as you can see, it's kind of marked. I don't know if it's too small to read, but that's my CPU fan. And the reason why it's important not to mix these up is because even though they look the same and the connectors would be identical, you could plug one into the other. The CPU fan is monitored by the motherboard's BIOS, and as such, you can use reporting tools and things to identify the exact speed that that fan is turning. That way, if, for example, something was going wrong and it was turning too slow, maybe it got gummed up with too much dust or the fan was going out, then it could send some kind of an alert through the motherboard back to you in some method so that you would know that you need to replace that fan. So the short answer there is always use the CPU fan connector only for the fan that goes to the CPU. All right, let's shift over here to the left a little bit further. Now there's a lot of different things over here that are of interesting note. Let me back out a little bit so we can get a better view of all the various components. One of the things I want to identify right off here is this big circular battery in the middle. Okay, right here. If a user complains to you that every time they shut their computer down and they start it up the next morning, the date goes back to some time in the way back. It's like they got in the way back machine and went back to 1980 or something like this. Well, that's probably because this battery that we're looking at, this coin battery, has died or it's not making good connections. Sometimes also a little acid can leak out of these and it can create a bad connection. So if that's the case, then what's happened is the battery's no longer supplying power to their BIOS, and as a result, it can clear some of their CMOS settings that they have. And this can be actually pretty devastating because it could wipe out things such as their RAID configuration or their hard drive configuration. You can reconstruct that potentially. Also, a lot of BIOS right now give you the capability of backing up the BIOS in advance, so if something like that were to happen, you could restore it after you had replaced this battery. Most of the batteries you'll see for motherboards are going to be CR2032. I think that's what this one is. Let's look in. So as I zoom in, yeah, it's a CR2032 coin battery. You can get them just about anywhere, convenient, not a convenience store, but a Target, Walmart, electronics supply store, Radio Shack, just about any place. One thing I do find kind of funny is whenever I've bought these, they don't let you buy just one. You have to buy a pack of 2. So they know that you're not going to need another one for another, 3 or 4 or 5 years, because these things do last a long time. And by then, you've probably lost the second one that you bought and hadn't used yet, so you'll still have to go back to the store and buy another 2. All right, and I kind of zoomed out a little bit there. Oh, I do want to show you again a thing about these fans as well. I have another graphic that shows that actually plugged in, which might give you a little bit better view of it. And you can see here this is on a different motherboard, but same idea. The CPU fan here, there's a little connector right here, and it's slotted in such a way or keyed in such a way that it can only go one direction. So that will help to protect you from making a mistake with the way you plug it in. And then shifting over here, we see a number of different slots and things, but I want to start off by going right to this battery. This is definitely something that has been, I think, a focus on previous A+ exam objectives, so let's address that. And actually, I also have a better photograph of one that zoomed in a little bit closer even. So let's take a look at that right here. Now, as we take a look at this, I want to identify that, you see how I've underlined the actual designation of this battery as CR2032. CR simply identifies that it's a manganese dioxide cathode, just in case you were wondering. Not going to be on the exam, just kind of a trivia item. And also the numbering here indicates the size of the battery. 20 means 20 millimeters in diameter, and 32 simply identifies that this is 3.2 millimeters thick. And then you can also see that it's a 3-volt battery down here in the lower left, right over here. These lithium cell batteries, which is what this one is and most of them are nowadays, they really actually start off a little over 3 volts, and you need at least 3 volts to be able to maintain power to the CMOS. It's actually the non-volatile RAM, but we kind of colloquially call it the CMOS as well. What does the CMOS do? Well, that stores information about how you've configured this computer, and it also stores information in conjunction with a clock. So if you have a user that turns on their computer and they say, hey, the computer says it's 1980. What did I do? Go back in the Wayback Machine or something like that? Well, more than likely, this battery has died and needs to be replaced. And if it's dead, it will reset the BIOS. That's one of the ways that the BIOS can be reset. Another symptom of a battery problem is if a user simply says, my computer's not keeping time. I mean, it's 12 o'clock noon, but it says it's only, 11:55, and every day it seems to lose a minute or two. Well, it's probably because this battery is starting to lose its charge. Lithium cell batteries actually do keep their charge for a pretty good long time, and it's usually only at the end of their life that they will then drop suddenly. But the key thing for A+ exam objective purposes is that for maintenance and repair purposes, when you hear a user complaining about things, especially relating to date and time, or that all of their settings have been wiped out, then it's probably because this battery has died. Also, if it does die, they'll lose other configuration information besides just things like the date and time. It could also be things like what devices boot first, whether it's the network boot or a CD-ROM boot or the hard drive. Maybe if they have RAID configuration set up in their main BIOS, then that would be another possible problem. If they have any power-on passwords that you have to enter in order to further boot the computer, all those types of things, plug-and-play information, all that kind of stuff could get wiped out with a dead battery. Oh, also, these batteries sometimes may get corrosion in them or something. And so underneath them, they may leach out a little bit of acid. That can cause a bad connection, so that you would also still need to replace the battery for that, but you may also need to clean those connections down underneath this battery. And you can very often do that with something like a typewriter eraser or a firmer eraser. Just make sure that you do blow out any of the dust or debris that it also creates in the cleaning process. And then if you do replace it, all you have to do is take a little jeweler's screwdriver or something, or maybe even your fingernail, and pull it up around the edges over here, and then it should come out. It's normally held in place by these retainers over here to keep it from popping out or something like that. Now, if it does come out, of course, you're going to clear your CMOS. Fortunately, a lot of CMOS nowadays can be backed up. Most motherboards have some method where you can save your CMOS maybe to a file or something, so that if you do replace the battery, you can get that information back from a restore. One thing I find kind of interesting about these batteries as well, by the way, you can get them at any electronics store, or even Radio Shack, or even like Kmart or Walmart or something like that. However, I find it kind of funny that you can only buy these normally in packs of 2. At least that's how I've normally found them. Which is kind of strange, because these batteries last between 3.5 and 5 years. So at the end of 5 years, you've probably lost the second battery you bought anyway, and you'd have to go back in and buy another pack of 2. Some kind of an evil, nefarious plan in that for a profit. Now, while we're here, I think I'm actually going to cover a couple of other issues before we get back to our main motherboard. Look at this rectangle up here on the printed circuit board. It says JP3. That's identifying jumper set 3. And this is going to be different on each motherboard. But what this is there's a jumper that's covering over 2 pins normally. And that would be pins 1 and 2, as you can see up here. And this would give you normal operation of your BIOS. But if you wanted to clear your BIOS on purpose, which is sometimes important if the user's, tried to get in there and tried to mess around with it, and they may have affected the normal operation of the computer, and you need to get back to a known good configuration, you can clear the BIOS by moving the jumper over to pins 2 and 3, and that will then clear that BIOS. So basically, 2 ways to clear the BIOS. Number 1, take the battery out, which I wouldn't recommend. A better way would be probably to just clear the BIOS by putting the jumper across those 2 pins. If you do it by taking the battery out on purpose, do be aware that you might have to leave it out for a little while, and it's kind of difficult to say how long. And that's because the motherboard itself does retain a little bit of a charge, and so we don't know exactly how long it would take for that charge to dissipate. But if you just wait a couple of minutes or so, normally you're going to be just fine. And here I just decided to take another photograph for you. This is 3 pins here. This is, for example, if this was a CMOS reset item. In this position, we would have pin 1 designated by the white arrow that you can see right there. That's just one way that they're commonly designated for motherboard items. If it were something like a flat ribbon cable and you needed to identify the first wire, or wire 1, that's usually going to have a red stripe on it, by the way. So anyway, this is pin 1. This would be then 2, and then this would be 3. In this position, if this was a BIOS or CMOS reset, we would be resetting the CMOS in this position. Also, this is one of the jumpers, and these are actually all very small. I know I've got the magnification larger. I used a macro lens to show you this, but they're difficult to grab sometimes. So that's why you might want to use a pair of tweezers, or even more likely, for me at least, would be needle nose pliers. Some of these jumpers will have a little indentation here that makes it easier to grab. You can just kind of put your fingernail in. It's easier to pull out that way. And then a jumper that I actually like better is this type, although I don't see them very often. And this is the normal height of a jumper right here, but you can see that it's got this extension on it, and it's also ridged so that it's easier to grab. And it's just a matter of preference for me, at least. This is the kind I like. And then here we see just the BIOS chip that appears on the motherboard. BIOS, by the way, stands for Basic Input Output System. It's the base programming for your motherboard. It says 1998 on there, but it's actually more up to date than that. You update this a number of different ways, which I'll discuss a little bit later on. But if you want to see the date and version of your BIOS, you can see that during the Power On self-test, which is also known as the POST, P-O-S-T, Power On self-test, and that'll identify that for you. And then returning to this graphic we were looking at earlier, I wanted to point out to you these switches down here in the lower right here, these DIP switches in this blue area. DIP simply stands for dual inline package, but that's not really important so much as the positioning of these. You see, if you were to flip one of these up, then that would change the programming of something on the motherboard. In this case, it might have to do with, the speed of the processor or the speed of a fan, or who knows. It could be anything that the motherboard manufacturer has designated, and just different combinations of up and down will send different instructions to the motherboard. For example, on older ISA PC cards, you could select the memory addresses of a card or the interrupt request, and that would actually take place on the actual adapter card itself. But I do have to point out that these DIP switches we're looking at right here on an old motherboard, I don't think you'll see these on any new motherboards anymore made in the past several years, because all of this can now be configured through non-volatile memory or the CMOS settings. And then returning to our motherboard here, we see a few slots here that I want to identify, and these are our PCI Express slots primarily, and that's mostly what you're going to see on newer motherboards. Also, I'm going to talk to you about them in more detail in a future nugget, but for right now, let's just identify what we have. This is a PCI Express by 1 slot. It's the shortest and narrowest of all of the PCI slots. There's the first one there. Here's the second one of the same speed, and then here's the third one. It's a little bit slower. That's because this is a version 1 slot, and these others are version 2, which are double the speed. I'll talk more about those, and I also have a PDF file that you can download later on when I talk more about these slots and the various expansion cards that you can insert into them in a future nugget. And then I also have other PCI Express slots here. There's also the possibility of PCI Express by 4 and by 8 and by 16. I don't have by 4 or by 8, but I do have one 16 there and another 16 there that I primarily are going to use for video. And then here we have a couple of other slots. This is a PCI slot right here. That's the first one there. And then there's my second PCI slot that we have here as well. Again, I have a PDF that'll describe those and the kind of throughput and the common usages for all of those. And then in many of the other nuggets we talk about, we'll talk about the various adapters that you can put inside of those. And then as an example, one of the kind of cards that you might put it, for example, in one of these PCI Express by 1 slots would be, I think I have a picture of one right here. There it is. This is just simply a serial ATA adapter card that I can put in the PCI Express by 1 slot. You can see how narrow it is, and the notch there would fit this exactly. And then here I would insert an internal connector for a cable to a PCI, or rather to a serial ATA hard drive. And then there's also an external connector here that I can use for eSATA. But again, I'll talk more about that in a future nugget. Alright, then having cleaned up my chicken scratch a little bit, and I've shifted over, and I want to point out a few things over on the far side of this. Here are some pins that we see, and this is useful for front panel audio connectors. So this is where you might be able to plug in speakers or a microphone or certain other kinds of high-end quality that you want to be able to directly connect to maybe the front or top in many cases of the case of your computer. And the kind of connector you would see connecting to that would be a block connector. And let me try to see if I can find one. Here's one, I think. Let's go to this. Yeah. And this is the kind of block connector that we would see with that. And this would just plug in. Notice that there's also one of these holes that's blocked up. That's to identify the proper orientation for this. And so you would take that and you would plug it into the motherboard. And although we can't really see this very clearly, I don't think, there's an empty slot right here where there's no pin. That's where that blocked portion of the block connector would orient on this particular set of pins. And then in addition to this, we also have a couple of other connectors here. Let's take a look at. This one is for a CD or a DVD drive audio connector. Don't really use those too much anymore because serial ATA drives will be able to send and receive audio, or rather send audio signals through the serial ATA cable, and that's how the audio signals get through. But if you have something like an IDE or enhanced IDE connector, then it may need to have a separate connector for sound if you want sound. And the other end of that would look like this, like that we see right here. So this is the actual plug end of that we would see. And that would, when it's actually plugged in, you might see it looking a little bit more like this right here. Okay, so now it's plugged in, and you can see that there's a little clip on it and everything. You just push that to pull it out. And it's a little bit out of focus, but you can see down here that it's identified as the CD audio connector that we see right on the printed circuit board. Further on down here, you'll see a connector like this, and this looks very similar to another kind of a connector, which would be, let me move up a little bit, this one down here. Now, they really look very much the same, and in fact, there's the same number of pins and everything. So it's easy to get those mixed up. You do have to identify these carefully. On this motherboard, this one's for 1394, which is also, FireWire, as we commonly call it. And this one down here would be USB. You just have to identify on the motherboard or in the manual which one is which and not get these mixed up. So you definitely do need to plug in the proper cable into the right one. So, for example, starting with this one up here, the FireWire item, what this would allow us to do is to plug in a block connector into this, which would lead to either an expansion slot in the back of the computer where we could plug in a FireWire cable, or we could plug this into the case, and the case probably has an external connector to FireWire as well. And let's take a look at what those connectors look like for both USB and FireWire. And here's a good example right here. And you can see again that they're keyed exactly the same, so there's a blank in one corner of both of these. And it's easy to plug one into the wrong place in the other one, and you could damage something by doing so. So you absolutely must make sure that you get these properly put into the right slots. And then back to our motherboard here, we see a couple of other USBs. This actually has multiple USB connections. I got USB ports all over the place on this thing. So let's see what else we got. Okay, down here, we're going to move into our serial ATA connectors. Now, two of these two white ones, are the latest version of serial ATA, which are capable of 6 gigabytes per second. So these are high-speed serial ATA, and then this one is just a conventional serial ATA. Now, also do notice the orientation of these connectors. They kind of have an L shape to them. Okay, that's the internal serial ATA connector. The external serial ATA type of a connector is going to look a little bit different than that. Now then, before we move down to the panel connectors down here, I want to identify this big square thing in the middle. Actually, let me zoom in a little bit this way. And this is just a heat sink that's over the top of the PCH that we talked about a little bit earlier. This also, by the way, just look at your manufacturer. They're all different. But this particular manufacturer has plastic film over it. You know, that clear plastic that you peel off? Sometimes you'll see that on the front of a new phone, for example, where you peel off the plastic off, so that it doesn't cover up the LCD and stuff like that. It's designed to protect it. Well, you do want to pull that off because otherwise it'll get hot and you wouldn't want that to melt or something. But other heat sinks that you might see for more traditional kinds of architecture would be maybe something like this. This is going to be a let me get rid of that mark there. This is going to be a traditional, more of a memory controller hub and I/O controller hub. This heat sink that we see here is over the I/O, or rather the memory controller hub, or MCH, and this one here is over the I/O controller hub. Okay, and we looked at the architectures in our last nugget. But both of those hubs can get pretty hot, and so you might see heat sinks over those. Definitely you don't want to remove those or alter those in any way. In fact, on the other side of this one, you can't really see it from this view, but there's actually a fan right here that additionally supplies cooling to that hub. And then returning here, let's go down to this bottom left section here. These are the panel connectors, and these connect to things on your case primarily. Things such as the the little beep speaker, so that if there's an error or something like that, or when your computer first turns on, you might hear just a beeping noise. There's also connectors for the LED for your hard drive, for your power. You'll see something there as well for the reset switch. And the power switches both. I have a better picture though, so let me show you that one here instead. On the motherboard here, we see a side view from a different motherboard. It's all the same stuff though, and this would have like an IDE connector here, so that it shows me anytime that the IDE hard drives are being accessed. There's also the power switch, the reset switch. This one's color-coded, so it makes it a little bit easier to work with. And then in the back here, there's something that looks very similar, and you might have identified it down here as well. This is a block of game pins back here in the yellow color. So if you have a gaming device, then you can plug that into this as well. What that would do then, on the other end of the cable that plugs into this, would normally go into an expansion slot in the back of the computer. It doesn't actually use a slot, it uses an expansion blank, I should say. And then you can plug in, a joystick or something like that into that particular port. And then here's a set of the connectors from the case that would be connected to, for example, this HDD LED would be connected to the LED on the case that flashes on and off whenever the hard drive is being accessed, and the power reset and so forth that you see over here as well. And the thing that's difficult about these is these can be, especially when the motherboard is installed, very difficult to properly put on those pins. A lot of times you're very tight in the amount of room that you have to work with. So I really don't like these things very much. But one thing that I do like that ASUS has is these Q connectors. And what happens with those is I take those same cables, but I put them onto this Q connector, and this is, I can just hold in my hand. And then I'll put, my hard drive LEDs over this one, and my, then I'll put my power over here, and then I'll put my reset over here. And then there's another side of this as well. That's one side of the pins. The other side of the pins would be like this. Oops, I gotta rotate this, I guess. There we go. And this would also have my speaker and my power LED and stuff like that. So I just plug those loose cables that I just showed you onto all of these things here, and then I take this whole block and I put it in a single installation over the top of the panel connectors on that corner of the motherboard. Much easier to work with. Then as we continue around here, we'll see the top of these connectors right here, which is for my serial ATA hard drives that would be inside the case. There's a much better picture of these if I look at it at a different angle like this. This is looking from the front of these. And again, you can see I've got 6 connectors here. In my particular case, I've got 4 of these that are set up in a RAID. We'll just define this a little bit better later on, but RAID 10, which is actually 1 plus 0, by the way. There's no such thing as RAID 10. We just call it that. It's actually RAID 1 plus 0. And this is a DVD here, and this is a Blu-ray player here. So I've got a couple of other things plugged in there as well. And then having shifted around over here, we see that we have a IDE connection here. It's actually an enhanced IDE or an EIDE connection. I'll show you a better view of this here in just a moment. On this motherboard, there's only one. In many motherboards, there's none anymore because these are becoming obsolete. But originally, there was a standard called an IDE connector, and this was a 40-pin connector. This actually still has 40 pins in it. Okay, but what this allowed us to do is to connect things like optical drives, like a DVD or a CD-ROM drive, and hard drives. But in recent years, this has largely been abandoned in favor of either one, enhanced IDE, which is what the one is that we're looking at on this motherboard. That's still 40 pins on the connector. But on the cable, you're going to see that there's actually 80 pins. Well, how does that work? I mean, how do you take 80 pins on the cable, or 80 wires, actually, I should say, 80 wires, and plug them into 40 pins? Well, half of the wires are just there for grounding. They don't actually connect to these pins, and because it's better grounded, you get better throughput through an enhanced IDE cable. By the way, this is integrated drive electronics or enhanced integrated drive electronics. And then I think I also have a picture here of a, here's a better view of it that we can see right here. Let me zoom out a little bit. And here we have these again. If you want to count them, there's 40 pins there. Actually, there's not quite. I guess I'm kind of lying there. One of these is blanked out, but we still call it 40 pins. And this is also keyed in such a way that on the actual IDE or enhanced IDE cable, there's a notch that fits into this opening so that you cannot plug it in backwards. Although some of the older cables did not have that notch, so if you're plugging in an older cable, you could still get it backwards and bend some pins over or something. If you do that, just use your needle nose, or rather, could be your needle nose pliers, but also I usually would use a jeweler's screwdriver to kind of leverage it back up. Not that I've ever done that, at least not much. Also, you might see on some of these that some of these maybe on one side or the other, they kind of slope. You know, they slope this direction or something. You know, it's like the wind has bent them over or something like that. This is normally a symptom that someone has not pulled out the cable at some time in the past straight up and out. Instead, maybe they reached in at an awkward angle and they were not able to pull it straight out, so they kind of pulled it, you know, to one side, you know, this direction or something like that. And that very often will cause these to kind of get a swooped angle to the side. And then down here at the bottom, this is very similar, but not quite as many pins. This is a floppy connector. This also is keyed with one blank there, and also in this case with a notch right here. But again, many floppy cables don't match up here. This motherboard does not have any way of designating which pin is pin 1 that I can see here anyway. Actually, it does. Right there it is. Very, very almost invisible. Right between these two, there's a 1 right there. So that would make this pin 1. I'll put 1 out here. Okay, 1. What you would do then is if you don't have any kind of notching or keying or any other way of telling on the cable which way to put this, if you can find pin 1, then on the ribbon cable for the floppy drive, the ribbon cable will have one red stripe on one side. The red striped wire is corresponding to pin 1. So if I were to plug in a cable here, I would put the red wire right on this one. Now then we'll talk more about this in the future when we talk about mass storage devices, but you might see these referred to as, again, IDE, which I've already discussed, or ATA, which stands for AT, which is the old initial PC standard, AT attachment. And then you may also see enhanced IDE, referred to as parallel ATA, okay, so PATA. But again, we'll talk more about those standards and serial ATA and some of the other connection types that you can use in a future point in time. Now down here we'll see a power connector. On a power supply you'll see a corresponding plug that goes into this. This is also keyed so that it can only go in one direction. And if we take a look at it with a connection actually in it, you'll see this is the plug that goes into that if we look at it from a straight down viewpoint. And that's a 20-pin connector. Also on this, there's a little notch down here that this clips onto, again, to prevent the power cable from working its way loose over time. And then here you'll see that we have memory slots, which we'll cover in great detail at a later point in time. But for the time being, let's go ahead and zoom in a little bit so we can get a little bit closer look at this. What you'll see here is when you insert the memory, you'll put it down, you'll push down straight on it, and there's a notching right here for the various types of memory. That would prevent me from putting, for example, DDR3 memory into a DDR2 slot or vice versa. Even though the dimensions of both of those memory are the same, they are actually different in terms of their other characteristics, so you wouldn't want to mix those up. And then over here is a lever. Most motherboards will have these levers on both sides. When there's no memory in them, you push these down, and so that they're kind of flopped open. And then when you press the memory down in, there's a little, let me show you if I can do this here. There's a little tab down here at the bottom of the slot that the memory module pushes down on, and then it automatically flips this up. It just kind of levers it up. That normally appears on both sides. This particular motherboard manufacturer just uses a straight slot on this side, however. And then finally, let's take a look at this one last connector. There's a block connector here for a serial port. You'll often see on the printed circuit board a COM1 or a COM2 or something like that to designate this as serial, and that's kind of equivalent. COM is usually serial. Serial ports are very often, in the old days at least, used for diagnostic purposes, so that if perhaps I couldn't even boot to an operating system, or I suspected there was a hardware problem with the basic hardware of my motherboard, I could plug in certain devices or diagnostic utilities into that serial port and receive diagnostic information from it, or I could connect an external serial port based modem. Again, those are very old. We don't really use those at all anymore. And then if you did make a connection and you needed this, then you would probably put the plug in there, and then it would connect to through a ribbon cable to a device that would go into one of your slots on the back of the computer. It doesn't actually use an expansion slots, but it uses one of the blank open slots there, looking like something like this. And then this would be the port on the outside of the computer that you could then plug into if you needed it for something. In this nugget, we took a look at motherboards, and this was part 2, which is really just a tour of the motherboard so that you can identify all the constituent parts of the motherboard and be familiar with it, such as the I/O ports. This could relate to sound, could relate to USB, to FireWire, all sorts of things. CPU, where you can identify where the processor actually goes, although we'll find out later that there are many different types of form factors for those CPU sockets. Same is true of memory, depending upon the kind of memory and the technology involved. But we took a look at least at the slots where you would put the memory, and we looked at also the various slots for things like expansion cards. I guess I could put on there expansion slots as much as anything. And then we took a look at the power connections so that you can power up that motherboard, as well as the panel connections, which are important to interface it with the case and for the LEDs and the power and reset switches and things of this nature. We also took a look at IDE, or more currently, enhanced IDE connections. Remember, these can also be identified as ATA or PATA. And then we also looked at SATA connections, or some people say SATA connections. Just depends, I guess, on who you're talking to. Well, I got to go out there and see what kind of chores my wife has for me on her birthday. I will tell you that I'm going to get my revenge, though, because my birthday is in only 10 days. And then I'll be able to get whatever I want. I think, anyway, as long as she allows me. Well, I hope this has been informative for you, and I'd like to thank you for viewing.